Hello everyone, now we are going to learn about non-weighted binary. Well, I know that you are pondering that what the access code is doing here because we have studied that access code or access 3 code is actually a weighted binary form. It's a sequential form too or sequential code as we have just studied. So what it's doing here? Well, let me tell you this first and let's get clarify on this. I mentioned it here again because it is also following the definition, the fundamental definition of non-weighted binary. Non-weighted binary means there is no sequence of the weight distribution exactly happening in the access 3 code. In the access 3 code, we just have to write it in BCD or 8421 form and then just add 3 or third position and select that third positions again and again. So this is the way the weighted binary is actually working. The non-weighted binary is also getting considered in this one. So I hope you have got the clarification. Because of this plus 3 sequence, now it lost its status as weighted binary and became the non-weighted binary. Well, I hope you have remembered. That's why I did not mention it initially, the access code in the weighted binary form. But later I told you that it's sequential form as it is showing some sequence. So it is sequential, but it is not weighted binary. So now I hope you have understood this and let's proceed to the gray code. So what is the gray code? Well, gray code is one of the most exciting concept in the binary world because there is sequence of numbers. To understand it more clearly, let's make a table so that we can understand the things quite clear form. So first of all, our favorite decimal number came, and then after we have binary, and after binary we do have gray code. So let's make it happen. Let me tell you a few of the things about this first so that you know that why you are learning the gray code. Well, gray codes are used where the synchronous and asynchronous system of the communication systems are working. It is helpful in few of the ways to detecting the error, which are known as parity bit and so many things related in the communication. So for now you can understand that its coding is helpful actually in the application form of the communication. That's why we are learning it. Okay, proceeding with the thing, let's write 00, 01, 02, 03, 04, 05, 06, 07, 08, 09, and then 10, which is 10, 11, 12, 13, 14, and 15. So here we have took total of 16 numbers as you are seeing 0 to 15 numbers. So in the binary form we all know that already. So just write it down very quickly. 0, 0. And well, you can try this exercise by pausing the video, write every number in the binary format, and I am just completing it till that time, and you can fast forward and just check that how much we have learned in the binary form. Okay, so let's begin. 0, 0, 0, 1. Well, you are not supposed to be here. Write it down and then come back. Well, if you came back, fantastic. Let's complete it and check that how many of the zeros and ones you have got corrected. Okay, so 0, 0, 1, 0, 0, 0, 1, 1. Then we have 0, 1, 0, 0. Well, if you have any kind of doubt, you can use the 8421 and write it down as your reference, and then can just follow simply this thing 0, 1, 0, 1, and then to write 6, 0, 1, 1, 0, then to write 7, 0, 1, 1, 1. And then we have to write 8, which is 1, 0, 0, 0. Then we have to write the 9, which is 1, 0, 0, 1. Now to write the 10, 1, 0, 1, 0. Then to write 11, 8 plus 2 is 10. So we just need one more number. And then to write 12, 8 plus 4 is 12. Then to write 13, 1, 1, 0, 1. Then to write 14, 1, 1, 1, 0. And then finally to write 15. So 8 plus 4 is 12, 12 plus 2 is 14, 14 plus 1 is finally, yes, you are correct, that is 15. So as you can see, we have written down every of the binary form and also practiced it. I am writing these all the things again and again so that you become that familiar in this mathematical section, so that wherever it's going to get used, you know that what's happening, and there should be zero confusion and 100% confidence in what we have learned. Okay, so now it's time for the gray code. So I am writing the gray code. Just think that what is different here. I let you ponder for a few moments and then we will discuss about this. So for that, let me also change the color so that you can get highlighted form of it. So first is 0000. It is very obvious one. Now the next one is 0, 0, 0, 1. Till this point everything is same, right? Now in the next form 0, 0, 1, 1. No, I have not written anything wrong. This is the gray code, remember? Now 0, 0, 1, 0. Yes, these two places are reversed. If you have seen that, excellent job. Now let's just complete it quickly and then I will tell you the pattern. Till that time, try to figure out that what actually is happening. You already got 50%, try to make it 100%. Then we have 0, 1, 1, 1, and then we have 0, 1, 0, 1. Then we have 0, 1, it's gonna be 100, 100. Okay, now we have 1, 1, 0, 0. Then we are going to have 1, 1, 0, 1. And then we're going to have 1, 1, 1, 1 first, and then we're going to have 1, 1, 1, 0, and then we're going to have 1, 0, 1, 0, and then we're going to have 1, 0, 1, 1, then we're going to have 1, 0, 0, 1, then we're going to have 1, 0, 0, 1. Well, don't get confused, these are just 16 terms because I have I left few of the blanks here, that's why it's seeming up and down, but these are pretty much the same. Okay, so what actually happened here? You got the point that here it became different. Now, let's just compare so that we can learn everything on the comparison front. So these two varied here. Now, Can you see this one? 0, 1, this is 100 if you simply say, which is coming down here, right? So here the sequence has changed. So now let's learn that how this happened and what actually gray code means. Well, you can write it down for till that time, the gray code in your notebook if you're writing, and I prefer that you write everything when you learn so that you understand it in a better possible way. So this variable weighted code is cyclic in nature. The most important word here, or the key word of the gray code, is cyclic nature. It is forming a cycle of the zeros and ones. How? And how it is different from other things? Let's look at that. Let me open the new page so that we can discuss the thing in more detail. So we are learning about the gray code, and till this time we have studied that it is cyclic in nature. So what the cycle means, now we are going to learn that thing. So it is arranged that every transitional from one value to the next value involves only one bit of the change. Hmm. One bit of the change. I'm saying it and then I'm writing it so that you can understand the words first, and then we are going to discuss it. Now, as we have written 0 0 0 0 for the 0 and 0 0 um, 0 1, and then we have written 0 0 1 1 first, and then we have written 0 0 1 0. I have written just 0 to 3, and now we are going to see what is the difference. In the binary form, when we needed to write, what we actually write? 0 0 0 0 0 0 0 1 0 0 1 0 and 0 0 1 1. Now on comparison you can see that we need to maintain two things, cyclic nature and only one bit of change. Well, we can write the only word here, only one bit of the change in every next term. So here this 0 changed with 1, so this is correct, only one bit of the change. Now but if we do in 8421 form, and this is our gray code, so in 8421 form what is happening, this 0 is changed to 1 or updated to 1, and this 1 is updated to 0, so 2-bit change. We didn't want that, we did not want that. So we discovered the gray code, which is 1 bit of the change here and only one bit of the change here, as it is already updated with the same number, and the next one there is only one bit of the change here, this remained the same. So this is the gray code. We require only one bit of the change. For that we shuffle our codes, and when we shuffle we have to remember that what we are picking immediately next or after next terms to take it upside. Now let's see our table again. So after this point you can see that what are the bits that have changed. So 0 is remained as 0, 1 is remained as 1, and this 0 get updated to 1, and next one this 0 is updated to 1, and then the next one this 1 is updated to 0. So this is the way it is happening, just one bit of the change. That's how this is working. I hope you have understood the gray code in a great detail now, and the gray code is also using the XOR table that we are going to learn in the digital logic design section for the further clarification. For now, congratulations, you have completed all the coding systems. So we have learned the binary system and I congratulate you here because you have crossed a very technical part which was quite mathematically, and a little bit you can say it is not so much of exciting, but it is going to be used. So we have learned a important tool here. So we have learned the binary, weighted binary, and non-weighted binary. So congratulations. And in the next one, we are going to see something exciting. After this boring stuff, it becomes my responsibility and duty to teach you something really exciting. So we are going to learn about the operators in the next one and the part of the algebra, the Boolean algebra. Yes, so we are going to learn about how the addition, subtraction, multiplication, identity, De Morgan's, and all these laws, which are commutative, associative, distributive, identity, and so on. So this will going to be exciting and logical. So we are going to see that and the operator precedences, that what you must prefer, like in simple mathematics we do prefer the system in which we take the BODMAS rule. In the BODMAS rule we used to say that BODMAS. So we solve the bracket first, then off, then division, then multiplication, then addition, and then subtraction. But this is not the same case in our systems. So we are going to see that how this system is working in the binary algebra world. So stick with me, stay tuned. God bless.